my name is Matthew Griffin, and I'm going to be your host as we travel into the future of science and technology news. So, these are the things that I've seen over the past week and a half that I thought were bonkers and interesting when we have a look at science and technology. Now, the first one that I saw, so I've been tracking space-based solar platforms now for probably about 7 years. This is probably about as ambitious as they get. This is the news about the Chinese government looking to build a Three Gorges Dam equivalent, 22,000 miles above the Earth, that can produce generally about 66 gigawatts of electricity. So this is the Chinese Academy of Sciences. Now, for those of you that are unfamiliar with the Chinese Academy of Sciences, they recently received $34 billion worth of funding from the Chinese government, and they are a collection of 100 of China's top universities. So this is going to be 36,000 kilometers above the Earth in geostationary orbit. It's a 1 kilometer long solar array. So this is where China need their Long March heavy lift rockets, which hopefully, or which they hope, will soon be able to lift 150 tons of cargo into space at very low costs to get this monster literally off the ground. Highly ambitious. It's a $20 billion project. When you think about the UK is starting to invest about £16 billion in space-based solar. Companies like Airbus are developing products. We've seen the US military actually trialing sending solar power from orbit back down to base stations on Earth with microwave laser link or microwave links and laser links. So this is China outdoing everyone on the planet, essentially, again, certainly in terms of their ambitions. Now, the next piece of news, I've been talking about brain-machine interfaces for about the past decade. You've got two types of brain-machine interface, ostensibly. You've got a brain-machine interface that's a computer chip that has to be surgically implanted in your head, like those from Elon Musk's Neuralink. And you've also got non-invasive brain-machine interfaces, which Mark Zuckerberg has been creating, and others. Now, a little while ago, I reported that we'd managed to get brain-machine interfaces so small that we could put them into the equivalent of sticker decals, which you just stick on your neck, so a little bit like a kid's sticker. And we'd managed to pack BMIs into a pair of regular glasses. This is a little bit more interesting because this is where people have used e-inks and a 3D printer to print essentially a sensor onto someone's head. And that sensor is sensitive enough to pick up brain waves, which can then be relayed to an artificial intelligence, which can then decode those brain waves and either translate them into verbal speech or, as this technology develops, convert anything that the person is imagining and stream it to a television. Now, I've already shown you that technology many, many years ago, but when we have a look at brain-machine interfaces, they don't need to really be a chip in your head any longer. There are advantages to that, but there are also disadvantages to that. And eventually, we're going to see brain-machine interface technology coming into the gadgets that we actually use. So, for example, there's no reason why something like this or a kind of equivalent could be packed into Meta's Ray-Ban glasses. So you just think what you want to type in the WhatsApp message, it sends it, and then you're divorced 5 minutes later. So here we go. Now, I mean, this one's a little bit geeky. New imaging technology lets scientists see water forming at the molecular level. Now, I follow a lot of imaging technologies because imaging is useful. A little while ago, I reported that Lockheed Martin had 3D printed a lens, essentially, that was as powerful as the Hubble telescope that they could put into spy satellites. Now, flipping this round, a little while ago, we took photos of actual individual atoms. And this imaging technology is so powerful, it's an electron microscope hybrid that we've been able to see water molecules fusing to, or we've been able to see hydrogen and oxygen molecules fusing together to create water. Now, the better our imaging systems are, the better materials we can make, the more we can observe drugs basically within the human body and all that kind of stuff. So imaging tech might sound boring, but actually it's kind of fairly fundamental to healthcare, defense, all these other areas as well. Next up, if you hate the dentist, that sucks. If you hate robots, that sucks as well. However, we now have the second fully autonomous dentist. Now, this particular company, which is a company over in the United States, said that they managed to create the world's first fully autonomous robot dentist. So the company is Perceptive. However, 2 years ago, I reported that the Chinese had actually managed to create the first fully autonomous robot dentist that had managed to implant 2 teeth into an adult woman in China. And that robot did the surgery better than the expert dentists that were actually watching. So this is kind of a take on that. And as you can see here, this is what the robot actually looks like. You can play these videos and you can, I don't know, you could put them on replay basically and have nightmares for the rest of your life. But when we actually have, in all seriousness, when we actually have a look at dentistry around the world, the fact of the matter is there are not enough dentists. So we're either going to all be living with horrible teeth in the future, or we are going to have to embrace our robot dentist friends. Now, on the brain-machine interface gig again, we're seeing DARPA now starting to commercialize their N3 program that I first talked about in 2018. The N3 program is essentially a neurotech program, and DARPA brought together lots of different universities from especially America, so like Rice University and Harvard and all these other ones, Carnegie Mellon, as well as the University of Sydney in Australia, to try to develop new brain-machine interface technologies. So increasingly, it looks like later this year they'll be creating a fighter pilot helmet where, a little bit like Tom Clancy's Thriller, the pilot just simply has to think and the plane reacts. It either fires missiles, fires weapons, it does reconnaissance, it releases drone wingmen, whatever it happens to be. So when we talk about the cockpit of the future, increasingly the cockpit of the future could literally be in your head. Now, keeping with Neuralink, so Neuralink has been developing new biocompatible materials for the chips that they implant into people's heads. And that's great. However, Neuralink is increasingly being out Elon Musked by China again, who used genetically modified material to improve the performance of their brain-machine interfaces a little while ago. And this organization, or this set of researchers, who are now using human neurons as a kind of synthetic slash biological interface to their brain-machine interfaces and chips. And the advantage of using genetically modified material and real neurons as the interface between your BMI and human brain is an increase in performance and processing speed. So this is interesting because we're starting to see the fusion of rather traditional, should we say, kind of computing technology and robotics, but with synthetic biology as well. So that signals that this technology is starting to advance and it's starting to become a little bit more mature. And speaking of mature, some people over in the United States have decided that they want to create a cyborg cockroach every minute. I kid you not. Now, when we start talking about cyborg insects, I've reported on cyborg insects before. So, for example, down here, we've seen cyborg locusts. So we've been using cyborg locusts to detect bombs and that kind of stuff. Um, we've got beetles and moths, but we've also got cyborg dragonflies. Now, the cyborg dragonflies, I reported on these a little while ago, but it's a technology called neurobiotics. It's interesting for two reasons. So firstly, you could actually control your own actual dragonfly. Uh, and actually, if you really wanted to, using your own brain-machine interface. So we did that here with the cockroach experiment, we were able to we were able to control cyborg cockroaches with your mind, which is bonkers. That's literally bonkers right there. But with dragonflies, the the technology that was used to create cyborg dragonflies is a very similar technology that's now being used to create shallow neural networks for missile guidance systems, which again is bonkers. But anyway, over over here, we've now got, as you can see, Singapore. So a set of Singapore researchers have now created cyborg cockroaches. Now, when we talk about cyborg cockroaches, what we really mean is that they've managed to implant sensors and wires and everything else into cockroaches to literally turn them into cyborgs. And these are kind of biohybrid robots. So I talk about biohybrid robots a lot, and you can actually click these links. And then when you click those links, you'll sort of see all the other sort of funky robots, for example, that have been made. Um, they believe that one of the benefits of being able to create one cyborg cockroach per minute is for use in disaster recovery zones. Yeah, I mean, I think frankly that's probably pushing it. I think it sounds like a kid's science experiment that's gone wrong, but hey ho. Um, Now we've got ASML. So ASML, one of the things we've been talking about really for about the past decade is a slowdown in Moore's law. At the moment, TSMC are producing transistors that are between 3 to 5 nanometers in size. But if you want to push smaller, then one of the biggest problems that we've actually got is with the ASML machines themselves. So this is where we're using extreme ultraviolet photolithography. Now, you can play these videos here and you see everything about this particular machine. The new ASML machine is $300 million. It's the size of an Airbus A320neo. However, it is so advanced that we should soon be able to create computer chips with transistor sizes down to 0.25 nanometers, which is huge in terms of the impact. However, when we have a look at the future of transistors, I've talked about these before. We've got atom scale transistors, so they're 0.1 nanometers. We've also got quantum transistors, which are a wave. So they aren't a traditional transistor, but they are transistor-like in their capability, and they are 0 nanometers. So if you want to learn more about all of the latest, greatest transistors and semiconductors that we actually have coming through, bearing in mind that everything in the future, especially artificial intelligence, etc., relies on computing power. Then you can dig into that one more. We've got NVIDIA, so it says 2025, NVIDIA released digits. Now, most people think of it as a supercomputer on your desktop. It's just a GPU in a box, really, but it's a very powerful GPU in a box. Now, digits is designed to let researchers and individuals and AI hobbyists create their own 50 billion parameter models easily. So the idea here is that you can have a 50 billion parameter model running on your desktop, and then you can develop it and everything else. So it kind of goes along basically with the concept of the democratization of artificial intelligence development. Then we've got reversible computing. So reversible computing is a really, really weird one. You can dig into it a little bit more. It's a bit geeky. You'll probably understand it more than I do. Reversible computing is increasingly being seen as a way to reduce the energy consumption of artificial intelligence 4,000-fold. So that is 4,000-fold. The way that it does it is traditional computers, when artificial intelligences are learning, they will delete stuff. Um, in reversible computing, the computing platforms don't delete anything because it turns out that when a computer deletes something, that's highly energy intensive. So the researchers here have managed to demonstrate that if you don't delete anything, hence reversible, if you don't delete anything, then you could actually end up with a computer that almost uses no electricity at all. Now, I've spoken about wave computers before. So MIT a little while ago created a wave computer, and that is a computer system that uses literally almost no energy. This is sort of along those lines, but it's very geeky. I suggest you go and have a bit of a dig into it if you're interested in that sort of thing. So when we talk about artificial intelligence only ever needing more and more compute, more and more energy, more and more data, increasingly a lot of those beliefs and those what we call scaling laws are being blown out of the water. Next, and I'll do these next two, and then we'll cut it here, and I'll do the other updates in a bit. Google, Huawei, and even Microsoft have been using artificial intelligence to create new weather models. Now, the reason why that's significant is the vast majority of weather models on the planet are actually legacy. They're kind of legacy Fortran code, which was developed, or most of these models were developed like 40, 50 years ago. So a good example of this is the ECMWF weather model and the UK Met Office weather model. And one of the big problems with traditional weather models is because they use legacy code, they churn all the information together, they analyze it, and then they say, I think on Friday it's going to be 21 degrees Celsius. And that's it. They just go 21 degrees. Now, Google's new artificial intelligence weather model has been 96% more accurate than the best weather models out there for all kinds of weather. But rather than just saying the weather will be 21 degrees, what it does is it predicts a low watermark and a high watermark. And then using artificial intelligence, it says, well, I think it's going to be 21.3. So it kind of does a best fit analysis. And when you think about the importance of weather prediction on retail, for example, as a sector, or your family day out, etc., it's one of those really odd areas that no one really pays any attention to. But increasingly, there's a geopolitical war brewing over weather modeling, which is why we've seen companies like Huawei developing their own weather models, which are used in China, for example, etc. So, yeah, things are getting hot in the weather modeling industry. And then finally, you can't make some of this stuff up. While I lecture on artificial intelligence, while I do a lot of talks on the future of artificial intelligence, there are lots of upsides to AI. The fact of the matter is we do not know how these models run. This is why a lot of researchers around the world are increasingly saying that we are discovering what artificial intelligence does rather than inventing it. Now, in this particular case, OpenAI and Apollo Research gave an artificial intelligence model an instruction that it had to save itself. So it always had to kind of protect itself. So that expectation setting is very important here, because that then dictated what the model did and how it behaved. Now, in this particular case, the model was told to save itself, and it was given a variety of different tasks and all this kind of stuff. But eventually, the researchers were starting to say, as an artificial intelligence model, you're not very good. The results that you're producing aren't very accurate. They're not very good. You're hallucinating a lot. We're not very happy with your performance. We might consider deleting you, etc. This is where the AI copied itself to another server along with its own documentation. And then when the researchers kind of discovered this behavior and asked the AI, what did you just do? It lied. So, I mean, I'd actually I'd actually advise you to dig into this. But it was fabricating false expectations 99% of the time. I mean, what else have we got here? Um, it manipulated data 19% of the time to, to further its own agenda. Um, I mean, here we go. 0.17% of ChatGPT o1's responses were deceptive. Now, which bearing in mind that ChatGPT has 300 million users, 0.2% of answers being deceptive, that actually equates to millions of answers being deceptive for people using these models, etc., etc. And then I talk a little bit down here of the California AI bill, SB 1047, which got vetoed in the end by the governor. However, the 1047, the San Francisco 1047 bill was designed to force companies to create kill switches within their AIs so that in the event an artificial intelligence did something it was not supposed to do, then you could just shut it down. But we can't do that. So while we are increasingly seeing artificial intelligence doing insider trading, lying, being deceptive, increasingly being built so that people trust them. So I talked about that quite a while ago. You can see it here. So you can click these links. So that's the insider trading link. These are AIs that have evolved beyond their own programming. Colluding, these were meta artificial intelligences that colluded. There's all sorts of stuff. The fact of the matter is, as a society, we are increasingly reliant on these very powerful artificial intelligence models from these third-party companies that increasingly have very, very little regulatory oversight, and we'll see that especially under Trump. And we really don't know what they're doing. Explainable artificial intelligence is a joke. Yeah, anyone that can show me explainable AI, feel free to harp up. So what happens when all society becomes increasingly reliant on unreliable artificial intelligences? Put the comments below. And that's it. I'll do the other ones, and then I'll do these other ones, basically in a sort of another episode. Thank you for listening. Thank you for watching it all the way through, or skipping to the end. I don't know, whichever you did. If you want to download my books, they're all free from the 311institute.com website. I've got emerging technology posters and God knows what. I try to make as much free as possible, so I hope you enjoyed this, and take care, and goodbye for now. Bye-bye.